we're going to write a linear function from a set of data points. So we're traveling in a car, our vehicle in miles per hour is starting at 0, so we're starting from rest. Then we go all the way up to 90 miles an hour in 6 seconds, so we're booking it. So let's write a function to model the situation. A couple different ways. Some of you will be able to see this very easily. So our interval is going up 1 second at a time, which is helpful to us. And then you see this, whoops, is a plus 15, plus 15, plus 15, and so on. So we know it's linear. And this is going to be f of t, because t is in time, equals, well, our rate, our slope, 15, t. And since we're starting at rest, that's it. That's our function. So this is our velocity, keep in mind. So let's figure out what f of 3 means. Equals 45. Well, we know this 3 means seconds. So this is at 3 seconds. Some of 45 is going on. This just means at 3 seconds, our speed is 45 miles per hour. So this is our rate. This isn't distance, it's our rate. So at, or after 3 seconds, after 3 seconds, our rate is, or our speed, you can say, is 45 miles per hour. Pretty straightforward, and that's it for that. So let's scroll down, and this is just a reminder, something you've definitely learned before, but something that we will use in calculus. So it's important, I thought it'd just be important to throw this in here while we're talking about linearity and slope, just so we're on the same page. So let's just write an equation through this point that's parallel to this line, and that's perpendicular to this line. So remember, we talked about parallel having the same slope. And just for the sake of using this point, which is going, actually no, never mind. We're going to call this x and f of x. Nope, g of x. All right, my apologies. So instead of saying x and y, I'm just throwing in a g of x instead to represent our parallel function. So this is going to be x and g of x. Okay. Put an equation through this point that's parallel to this line. So we know that our slope is going to be 5 because it's going to be the same slope. So that means g of x is going to equal 5x plus something. But we don't know yet because it has to be through this point. So what we're going to do is plug in this 1 and 7 into this equation so that we can solve for b, because this is a point on this line. So we can use it to find the y-intercept. So g of x is 7, and that equals 5 times x, which is 1, plus b. So then if we solve for b, this is just 5, we subtract 5 from both sides, we get 2 equals b. Which means our equation is g of x, our function, not equation, g of x is 5x plus 2. And that's it for that one. Let's find the line that's perpendicular to this line and goes through this point. So let's go. I guess I'll just use g of x again, just keeping in mind that these are going to be 2 different lines. Nah, just kidding. I thought about it. We're going to use h of x. H of x is going to equal opposite reciprocal slope. So the slope is 5, so that means the opposite reciprocal will be a negative 1/5 slope. X plus something. We're going to do the same process to solve for that b, so we're going to replace h of x with 7. It's going to equal negative 1/5. X is 1 plus b. Ugh. All right, negative 1/5 times 1 is negative 1/5. I'm just going to write this as a mixed number. So 7 and 1/5. Or I guess I could put 7.2. That would be okay too. Equals b. So this equation, I said it again, this function is our slope, negative 1/5 x, plus 7 and 1/5, and that's it. So really the key here is the slope. Parallel slope is the same slope. Perpendicular slope is the opposite reciprocal. And then knowing how to solve for b given a point and a slope. How to write the equation while giving a point and a slope. I also could have just used point slope form, which we can review if you would prefer. So just email me if you would like to know how to do that. This is just fine as well. So that's it for this video. Email me if you have any questions.